So now that we've seen how to solve linear equations in one variable, the next step in the process here is to think about, well, okay, what about inequalities? How would we go about solving linear inequalities in one variable? And the answer to that is, with one exception that we'll get to in a minute, exactly the same as we did with equations. The steps are practically identical. So I've got an example here for us to take a look at. And if there were an equal sign in there in place of the greater than, you would know exactly what to do, right? Because we have a process that we've talked about already. I'm going to follow exactly the same steps. We'll start by distributing the 3 into the parentheses. This will become 1 is greater than 3x minus 15. We'll add 15 to both sides. 16 is greater than 3x. And then divide both sides by 3. 16 thirds is greater than x. And yeah, technically we're done. But remember when we talked about equations, I said stylistically, we always want the x to be on the left in our final answer so that it reads like an English sentence. X is 12 or x is greater than some number. We want to do the same thing here, right? We want to turn this around so that the x is on the left side and the 16 thirds is on the right side. Now, when you do this, you have to be a little careful with the inequality symbol. Its direction, the way I think of this, its direction has to stay the same. And in the final result here, it was pointing at the x, so to speak. I needed to do the same thing on the next line when I turn it around. So I'm going to say x is less than 16 thirds. Right? And that'll be my final answer. Now, that's a perfectly good way to write this. Sometimes you'll see situations where somebody really wants you to be more formal about this. You could also write this. This is the set of all real numbers such that x is less than 16 thirds. And that's awfully formal for me. Most of the time in class, I would call this a perfectly good answer and be okay with students stopping there. Another way that you will sometimes see these answers written is using the interval notation, right? The interval notation answer for this would be negative infinity up to 16 thirds. And I will put a parentheses there because I have strictly less than here. So I don't want to include 16 thirds in the answer. If this had been, just hypothetically over here, if my answer had been x less than or equal to 16 thirds, then the interval notation version would be negative infinity up to 16 thirds again. And I will put a square bracket there to indicate that I want to include 16 thirds. So how about that special rule that I told you about, the one extra rule that we have to have in our toolbox for when we're solving linear inequalities? Well, it has to do with what happens when you're dealing with negatives. So let's look, for example, we know that 1 is less than 2, obviously, right? 1 is over here to the left of 2 on the number line. Numbers to the left are smaller than numbers to the right. Okay, fine. Now, what if I multiply both sides of this inequality by negative 1? Right, if I do that, what happens? Well, this becomes negative 1 is less than negative 2, and that is incorrect. You can see if you look down at the number line here, negative 2 is to the left of negative 1. So negative 2 is the smaller number. So that is not correct. And that brings us to our special rule for working with negatives. Anytime you multiply or divide an inequality by a negative number, not only do you change the numbers, you also have to change the inequality. So this less than is going to turn into greater than, and now I have a true statement. Negative 1 is greater than negative 2. And you can kind of see why if you look at what happens when we multiply by negative 1. The 1 became negative 1, and the 2 became negative 2. So you can kind of see how multiplying by a number does what's called a reflection. It reflects the numbers across this middle point here at 0. And if you want to think of it as being like a mirror image, or when you look at something in a mirror, you know how things get reversed? It's the same thing here, right? When we multiply both sides of an equation by a negative number, the order of the two parts gets reversed. And to represent that, we have to switch the direction of the inequality. All right, so let's look at an example of that so we can see what's going on here. I'm going to do what we always do. I'm going to start by adding 5 to both sides. This becomes 4x less than or equal to 5x minus 7. Now we'll subtract 5x from both sides. Negative x is less than or equal to negative 7, and you see here we have that special case. My next step, I'm going to have to divide both sides by negative 1. Now, I'm really picky about it when I'm writing this in class. Normally, if I wanted to divide both sides by a number, I would just divide by that number on both sides. But here, you have to be careful, because if I do this, that is not true, right? Because when we do that negative division, the inequality has to change. So I'm super picky about this when I'm writing it out. I would actually write this over again on a new line. I would say negative x divided by negative 1 is greater than or equal to negative 7 divided by negative 1. And then I get my final answer. X is greater than or equal to 7. Right? And if you want to do this in the interval notation, right, that's really a popular way of writing these in a lot of textbooks today. I would do square brackets, 7 up to infinity. I usually put the plus sign in front. It's just kind of a habit. If you just put infinity there with no sign in front of it, that will be fine too. Okay, so before we move on, I want to take another look at this. Let's try doing this again. It's possible that if you're looking ahead to dodge this whole problem of reversing the inequality. Let's say, I'm just going to write the equation over again. 4x minus 5 is less than or equal to 5x minus 12. Let's say I subtracted 4x from both sides. Right, then they're going to cancel over here, and I get minus 5 is less than or equal to positive x. See how I avoided getting a negative sign in there? Minus 12, and then we can add 12 to both sides, and I get 7 is less than or equal to x. I remember what I said on a couple slides back, right? We want to lead with the x instead of end with it. So if I want the x first and the 7 second, I can do that, but I have to keep this pointing towards the x. And look at where I ended up, right, with exactly the same thing either way. Okay, so either remember the rule or avoid the rule, right? Either way, you're going to end up with the same answer. All right, so that's solving linear inequalities in one variable. And just like we saw when we're solving equations, there are two special cases that can come up here that you need to be aware of. And that's what we're going to look at in the next lecture.